Good morning, my friends. My name is Kipechi and my friend is Kwejasha. Today, we are talking about nuclear power generation. So first, we want to know what is the nuclear energy. Look at this. The nuclear energy is a form of energy to release from the nucleus. This nucleus is a core of an atom, and it makes up from protons and neutrons. This source of energy can be produced in two ways. The first one is nuclear fission. It will be occur when nuclear atoms split into several parts and normally used in power plants. The next is the nuclear fusion. It occurs when the nuclear fuse together occur in stars or future energy source. Okay, now we are talking about the principle of nuclear energy. The first one is nuclear fission. It is a reaction where the nucleus of the atom split into two or smaller nuclei, and it will be release the energy. Example, it will release this energy, uranium U-235. The next one is controlled chain reactions. In a nuclear reactor, a chain reaction is controlled using control routes or moderators to prevent an uncontrolled explosion. Let's talk about the control routes. Control routes is made from boron or cadmium. It helps to absorb excess neutrons and regulating the rate of fission. The next one is moderators. The moderators is used with water or graphite. It helps to slow down the neutrons and making fission to be more efficient. The next one is heat generation. When fission occurs, a large of energy is released in form with a heat. This heat will transfer to a coolant, and the coolant usually uses water, but sometimes use liquid natural gas. The next one is steam propulsions. Steam propulsions is the heat from the reactor core is used to turn water into steam in a steam generator. And the next one is electricity generation. The steam drives a turbine and connected to a generator, which spins a mechanical energy to produce the electricity. After passing through the turbine, the steam is cooled and converted back into the liquid in a condenser, where it is for reuse in the system. And the last principle is radioactive waste management. Nuclear fissions decrease radioactive byproducts of fission needs proper disposal. It helps to safety can handle and stores the nuclear waste. Now, we are talking about the advantages. The advantages are four. The first key of advantages is extremely high energy efficiency. Nuclear energy has much higher energy density than fossil fuels. Just 1 kilo of uranium-235 can generate much energy as 2,700 tons of coal, meaning that less of fuels is needed to produce more electricity. And now we think about low carbon emission and environmental benefits. Unlike coal and natural gas, nuclear power plants produce almost zero carbon emissions, helping to combat climate change and reduce air pollution. The next one advantages is reliable and stable energy supply. It's not like the solar and wind power. Nuclear energy is not affected by weather conditions like summer days, snowy days, rainy days, and it can provide a continuous 24 hours per day electricity supply, and it can ensuring the energy stability. The last advantage is future functions of nuclear fusions. According to scientists, they are researching nuclear fusions, which could be more safer, cleaner, and nearly limitless energy sources. And it is no radioactive waste. If this researching is successful, fusion could revolutionize global energy production. Now we are talking about the advantages of nuclear energy. The first challenge is radioactive waste management. Nuclear reactors produce radioactive waste, and each can take thousands of years to decay and must be stored steadily to prevent its contaminations. The next is the high construction cost and long development time. We want to build a nuclear power plant. It requires billions of dollars and often takes more like 10 to 20 years to complete the power plant. And also, the maintenance is very expensive on that time. Okay, the last one is risk of nuclear proliferations. Nuclear proliferations, like this photo, it will like explosions, and our nuclear technology can be used to develop nuclear weapons, raising security concerns and geopolitical tensions. Okay, the advantages is already finished. Now we are talking about the process of pressurized water reactor. Okay, look at this picture. The first, we were using the splitting of uranium atom to produce the nuclear energy in the reactor core. And the control routes is one. We will control and observe the neutrons and regulating the rate of fission and its coefficients. After these control routes produce the energy, right? And it will release in form of heat in pressure tank to prevent it boiling. Then the heat from the reactor core will transfer to the steam generator and mix the steam in these systems. After the transfer energy, the water will pump back into the reactor itself for reuse again. After the energy, the energy transfer to the turbine, and the steam will convert back into the liquid water in this condenser for reuse again this process. Lastly, the electricity will transfer to the transmitter tower from the electric generation station. The transmission power will transfer to substation, and substation will support the electricity to industry, resident building, or commercial building. And here, we can look at this, here, and here, all are for the reuse systems. And now, we're talking about this example country that use. For the nuclear power generation, mostly country that use is United States, US, France, and China. For the US, it's the more largest producer of nuclear energy with numerous records across the country. It can be 20% of nuclear share of the 20% of total electricity generation in the US. The next one is France. It has heavily reliant on nuclear power, which accounts for about 17% of its electricity. The next is China. It rapidly expanding its nuclear energy capacity as part of its strategy to reduce the carbon emissions. Okay, we can look at this picture. The table is at August 2021, but this data available as 2023. Here is the top 5 nuclear electric generation capacity countries. That we can see that US, France, China, Russia, South Korea, and the capacity that used in million kilowatts. You can see the US is more using this nuclear energy, and South Korea is lower using. But you can see the France are using total electricity generation are more than US and other countries. So you can see that the France is heavily reliant about the nuclear energy. So that we can see about the pressure water reactor process. Okay. Now we want to share you about what is the details of nuclear power plant process.
The process of creating electricity using nuclear power begins with the splitting of uranium atoms in the reactor. This process, called fission, produces heat. In a pressurized water reactor, the heat from the water surrounding the nuclear fuel is kept under pressure to prevent it from boiling. The hot water is piped from the reactor vessel to a steam generator, where it transfers its heat to boil water and makes steam in a second system. After transferring its energy, the water is pumped back to the reactor vessel to be reused. The non-radioactive steam from the steam generator spins turbines that drive the generator to produce electricity. After the steam is used in the turbines, it is drawn into a condenser, where it is cooled and condensed back into water and pumped back to the steam generator to be heated and reused.
Okay, that's all. Okay, this is our process of pressurized water reactor. In conclusion, nuclear power generation is a double-edged sword. It offers high efficiency, low emissions, and reliable power. It also poses accident risk and waste disposal challenge and security concerns. The future of nuclear energy depends on advancement in safety, technology, waste management, and public perceptions. As nuclear fusion technology develops, we may one day achieve a cleaner, safer, and limitless energy source. So, should we embrace nuclear energy as the future of power, or it is a thinking time bomb? This answer is still up for the debate. That's all for my presentations.
Thank you for listening my presentation. Bye.